Hello everyone, I am Kritvi Jagatramka and today I will be giving a comprehensive report on the jet engine components. To give you a roadmap of what to expect, we will start with an overview of the key components, including the fan, air intake, airflow inside the jet engine, low pressure and high pressure compressor, combustion chamber, high pressure and low pressure turbine, nozzle, and the overall working of the jet engine. Let's start up with the fan. The fan is typically constructed with titanium blades due to its high strength to weight ratio, corrosion resistance, and ability to withstand high temperatures. The primary function of the fan is to draw large amount of air from the environment, making the initial step in the power production of the turbo fan engine. Now let's talk about the air circulation within the engine. The drawn air is directed in two main directions. A part of it enters the core of the combustion, while rest of it is known as bypass air, circulates through the outer channels. This bypass air has multiple functions, including contributing significantly to engine emissions, aiding in cooling, reducing noise, and enhancing the overall efficiency. Now let's talk about the low pressure compressor. The low pressure compressor consists of rotating and stationary blades working together to compress the air efficiently. The rotating blades or the rotors draw in the air and impart kinetic energy, while the stationary blades or the stators guide the airflow and convert the kinetic energy into pressure. This multi-stage compression process ensures that the air enters the combustion chamber at a required pressure for efficient combustion. Now let's talk about high pressure compressor. The high pressure compressor increases the pressure of the compressed air to a higher level, preparing it for the combustion process. This stage is crucial in ensuring that the air entering the combustion chamber meets the conditions required for effective fuel combustion, contributing to the overall power generation of the aircraft engine. Now, the combustion chamber. Once the air has been compressed in the high pressure compressor, it enters the combustion chamber where the fuel is introduced. The mixing of the air and the fuel is ignited, creating a high pressure environment. The fuel is injected into the combustion chamber in a carefully controlled manner. The ratio of air to fuel, known as the air fuel ratio, is crucial for the effective combustion. This controlled combustion generates a stream of hot gases, propelling the engine into action. The efficiency of the combustion provides direct process directly influences the overall performance of the engine. Advanced engine design focuses on optimizing combustion for enhanced efficiency, reduced fuel consumption, and lower emissions. Now let's talk about the high pressure turbine and the low pressure turbine. In the high pressure turbine, after the fuel and the air are combusted in the throttle, high pressure and high temperature and high pressure gas flows through the engine. This hot gases is directed to a high pressure turbine. The energy transfer from the compressor is through the rotation of the high pressure turbine is not only the result of the energy extracted from the exhaust gases but also the source of energy from the compression of the engine. The rotation turbine is connected to the high pressure compressor and the rotation of the turbine drives the compressor. In the low pressure turbine, the fan is connected and the low to the low pressure compressor. The fan is large, multicolored component in front of the engine that draws in a large amount of air and accelerates it. The low pressure compressor is responsible for compressing this air before it enters into the combustion chamber. Now let's discuss the function of the nozzle. In the nozzle, the high speed air is produced during the combustion processes is expelled from the engine through the nozzle. This high velocity airflow is an important factor in propelling the aircraft. Now let's discuss the relation between CL and alpha graphs. These graphical representations are fundamental in understanding the aerodynamic characteristics of an aircraft and play a key role in its performance. The climb graph, denoted as CL, illustrates the relationship between lift and drag at various angles of attack. It helps pilots and engineers understand how changes in aircraft's angles of attack affect its climb performance. This is crucial for optimizing ascent and descent profiles during the flight. On the other hand, the angle of attack, represented by alpha, is a measure of angle between the incoming air and the reference line of the aircraft, typically the chord line of the wing. The alpha graph depicts how the lift and the drag vary with angle of attack. Pilots use this information to determine the optimal angle for the aircraft to maintain a stable flight. Now let's discuss the different kinds of jet engines. First one, we have turboprop. Turboprop engine takes inspiration from both jet engines and propeller propulsion. Instead of relying solely on a jet stream, turboprops utilize a gas turbine engine to drive the propeller. This igneous design makes them highly efficient at lower speeds and shorter distances, making them ideal for regional and short haul aircraft. Next one, we have turbojet engines. These engines operate on a fundamental principles of air compression, combustion, and exhaust propulsion. These are the pointers of jet propulsion generating thrust through the expulsion of high speed exhaust gases. Turbojets have streamlined, designed, and are often employed in military aircraft and supersonic jets. Next, we have turboshaft. In the world of the rotatory wing aircraft, we encounter turboshaft engines. These engines deviate from the traditional model by connecting the output shafts to the mechanical devices, such as the helicopter rotors or the wheels of the military vehicles. Turboshafts provide the high power output required for these specialized applications. Next up, we have turbofan engines. These engines represent a remarkable evolution in the jet engine technology. Unlike turbojets, turbofans incorporate a bypass mechanism allowing a significant portion of the incoming air to bypass the combustion chamber. This bypass air contributes not only to the thrust but also enhances fuel efficiency. This design is a hallmark of modern commercial aviation, offering quicker operation and improved fuel economy. Next, we have ramjet engines. The ramjet engines are a different breed altogether. Unlike traditional jet engines, ramjet engines do not have a compressor. Instead, they rely on a forward motion of the aircraft to compress the incoming air. This unique design makes them highly efficient at high speeds, making them suitable for application where sustained high velocities are crucial, such as missiles and certain experimental aircraft. To conclude, I would say that it's clear that these marvelous things. The key takeaways include the importance of the fan in the air propulsion, the role of the compressors in preparing the air for combustion, and Significance of the turbines in extracting energy from the hot gases produced during the combustion. The nozzle, as the final stage, plays a crucial role in converting the high velocity exhaust gases into forward thrust. As we look to the future, advancement in jet engine design will continue to focus on the enhancing efficiency, reducing environmental impact, and meeting strategic noise regulations. The knowledge gained from studying these components forms a foundation for the next generation of the aviation technology. Thank you.